We're now going to look at some projectile motion multiple choice questions. So this is a multiple choice question. A projectile is fired at an angle alpha to the horizontal at a speed u as shown. What are the vertical and horizontal components of its velocity after a time t? Assume that air resistance is negligible. The acceleration of free fall is g. So just taking the horizontal component of the initial velocity, we know that that's going to be the adjacent side here. So cos of alpha is equal to adjacent over hypotenuse, so it's going to be u horizontal over u. So u horizontal is equal to u cos alpha, and we know that assuming air resistance is negligible, which it does say that in the question, we can assume that this horizontal component of velocity is going to be constant throughout the duration of the flight. So if we're looking at the velocity after a time t, then the horizontal component is going to be u cos alpha. And then if we look at the vertical component, we're going to need to apply a suvat here. For example, if we use v equals u plus a t, that would give us the velocity after a time t. Then we're going to need to put in for u the vertical component of the velocity, which is now we're now looking to find the opposite side of that triangle, and we know that sine of alpha is equal to opposite, so that's u vertical component over hypotenuse. So u vertical is equal to u sine alpha. So we'd put that into our equation as the initial vertical component, and then the plus at bit will have to be minus gt, because we're thinking about directions here. So if we're saying that our vertical component of velocity upwards is positive, then our downwards gravity will have to be negative. So that gives us u sine alpha minus gt. So we're looking at answer C there. Question 2. A tennis ball is thrown horizontally in air from the top of a tall building. If the effects of air resistance is not negligible, what happens to the horizontal and vertical components of the ball's velocity? So if air resistance is not negligible, then we know that the horizontal component of the velocity isn't constant. And in many of the examples, we're actually told to ignore air resistance as a simplification, and we can say that the horizontal component of velocity is constant to really simplify things down. But actually, if there is air resistance and we need to consider it, then it's going to be acting as a force which is in the opposite direction to the motion of the ball, and that's going to be decelerating the ball so that its horizontal component decreases to 0. So we're looking at either C or D. And thinking about the vertical component, there's going to be weight pulling down on the object, but as it increases speed, there's going to be a drag force or an air resistance acting upwards. And that drag force is going to increase with speed to the point where it exactly balances the weight and terminal velocity is reached. And so the vertical component of the velocity increases to a maximum value. So the answer here is D. A ball is thrown vertically in the air. Neglecting air resistance, which property of the ball can never be 0 at any time during the flight? So the only property of the ball that can never be 0 is acceleration. At any point during the flight of the ball, it will have the same acceleration acting on it, ignoring air resistance. It's always going to have the acceleration of gravity acting directly downwards. So even at the top, even when the ball is moving upwards, it's got an acceleration downwards, and even at the very top even when its velocity is 0, it's got an acceleration downwards. So the acceleration is never 0. The velocity can be 0, so right at the very top. Velocity is speed with a direction, so that means the speed, which is the magnitude of the velocity, can also be 0. And kinetic energy is a half mv squared, so that can also go to 0 if the velocity can go to 0. So the answer here is A, acceleration. Question 5. In the absence of air resistance, a stone is thrown from P and follows a parabolic path in which the highest point reached is T. The stone reaches point Q just before landing. The vertical component of acceleration of the stone is A, 0 at T, B, larger at T than at Q, C, larger at Q than at T, or D, the same at Q and at T. So at all points in the flight, the vertical component of acceleration is going to be the same. And we're ignoring air resistance. So that means that at all points in the flight, so at T and at Q, there's the acceleration of free fall, or G, which is acting on the object, which is acting directly downwards. So the answer here is D, the same at Q as at T. Question 6. A projectile is launched at point O and follows the path O, P, Q, R, S as shown. Air resistance may be neglected. So which statement is true for the projectile when it is at the highest point Q of its path? So the answer here is A, because the horizontal component of the projectile's acceleration is 0, and if we can ignore air resistance, then we can say that the horizontal component of velocity is a constant. So really, wherever you looked, the horizontal component of the velocity would be the same value. So that's true for the top of the flight. I'm looking at the others and why they're wrong. So B, the horizontal component of the projectile's velocity is 0. No, it hasn't stopped horizontally. It may have, well, at the highest point, it will have a 0 vertical component. So that would be correct if it was vertical component there, but it's not. It's horizontal, so it's wrong. The kinetic energy is 0. Well, that can't be right, because if it has velocity, then it can have kinetic energy, which we know we can calculate from half mv squared. That's got velocity in it. The momentum of the projectile is 0. Again, momentum is mass times velocity. So if it has velocity, then it must have momentum. So the answer here is A. Question 7. A cannon fires a cannonball with an initial speed v at an angle alpha to the horizontal. Which equation is correct for the maximum height h reached? So we need to look at the vertical component of the initial velocity, and we're going to find this component here, which is the opposite of this triangle. And we know if we've got opposite and hypotenuse, we can use sine. So sine of alpha is equal to, we'll call it u vertical, opposite over hypotenuse. So uv is equal to v sine alpha. And then we're going to put that into an equation, which is v squared equals u squared plus 2as. We're trying to find s, which is the height there, displacement. So rearrange that, we get v squared minus u squared over 2a. A is equal to minus g. So v is 0, that's the top of the flight, so 0 minus v sine alpha squared, that's our u squared value, over minus 2g. The negatives cancel out there, so it gives us v sine alpha in brackets squared over 2g. So the answer is C. Question 8. A motorcycle stunt rider moving horizontally takes off from a point 1.25 metres above the ground, landing 10 metres away as shown. What was the speed at takeoff? First thing here is to consider the vertical component to find the time t. So we can use a suvat, s equals ut plus a half at squared, where the initial vertical component of velocity is 0 and a is equal to g. So we've got s equals a half gt squared. Rearrange for t. T equals 2s over g square root, where s is the vertical drop, so 2 times 1.25 over 9.81 square root is equal to 0.5 seconds. And we've been in the air for 0.5 seconds and we've travelled 10 meters horizontally. So speed equals distance 10 over time 0.5, which equals 20 meters per second. And we're saying that that's a constant. The horizontal component of velocity is constant here, and just using distance divided by time to calculate it. So that gives us answer D, 20 meters per second. And question 10, at time t equals 0, a body moves from rest with a constant acceleration in a straight line. At time t, the body is distance s from its rest position. A graph is drawn of s against t squared as shown. Which statement describes the acceleration of the body? So the equation to use here is s equals ut plus a half at squared. It has s, t and a in it. The object is dropped from rest, so that means that u is 0. So the equation simplifies to s equals a half at squared. And using our knowledge from maths of y equals mx plus c, if we've got on the y-axis, we have got s. On the x-axis, we have got t squared. Then the bit that's multiplying by t squared there is going to be our gradient m. So that means that the gradient of this line is going to be equal to a half times the acceleration. So gradient equals a half times acceleration. So acceleration is going to be equal to 2 times the gradient. So we're looking at answer C there. It is equal to twice the value of the gradient of the graph. And well done for completing these multiple choice questions on projectile motion.